Welcome to lesson 7.2 high tide. We're going swimming today, hopefully. Um, okay. Let's dive into we have a lot to cover today. Let's kind of start talking about the ready part, right? So recall that the right triangle definition of the tangent ratio. So tangent um, is so this is remember this is the angle, right? A is equal to the length of the side opposite angle A, so this is my opposite, over my adjacent. This is my adjacent, right? So again, this goes back to doa, doa, or all lowercase, whatever makes you feel better. Some people like seeing it all uppercase. Doa, 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 right? Okay, so solve for y, then find excuse me, then find the tangent of A and the tangent of B. Okay, so we have a right triangle, right? We are given this. So then again, this is Pythagorean theorem. So A squared plus B squared equals C squared. Okay. Um, doesn't really matter what A and B are as long as these are my legs. And this right here is my hypotenuse. Okay. So let's kind of just put this over here so we can reference it. A, we'll call this 56 squared plus, we'll call this y squared, we'll call this b, right? Equals to 65 squared. So then we get that y is equal to, I'm going to skip some of these steps. We should feel pretty comfortable doing this by now. And I'm going to put this into my calculator and do square root of 65 squared minus 56 squared, and that gives us to be 33. So then y is 33, right? That's kind of my first. Okay, now I'm talking about tangent of A. So this is A. So is opposite over my adjacent, 56. Okay, and now we're gonna switch it up a bit and talk about B. So opposite is 56 over my adjacent, which is 33. Okay, so I want you to notice that these are what? What are they? These are reciprocals of each other, right? Reciprocals. I don't know how to spell reciprocals, but yes. Okay. Let's kind of go into question 2. Solve for x, then find tangent of A, tangent of B. Same concept. I'm going to use my Pythagoras theorem. X squared plus 9 squared equals 41 squared. X squared plus 81 is equal. 41 squared is 1681. X squared is equal to 1600. X is equal to 40. This is 40 right here. Okay. And then tangent of A, this is A, is opposite over adjacent, which is 40. And then I'm going to switch it up a bit. And then I'm talking about B here, is opposite is 40 over my adjacent. So 40 over 9. Okay. Let's go. I hope that's making some sense. Let's talk about y. Okay, so same concept. This is my hypotenuse, and this is my one of my legs. So it's 21 squared plus y squared, 29 squared. So I get that y is equal to the square root of 29 squared minus 21 squared. Let's do it. Nope, not there. Square root of 29 squared minus 21. Nope, that's not right. Is equal to 20. 20, 20. So then I get that y is 20. 20. Okay, now tangent of A. This is angle A. I'm talking about opposite. So directly across is 20, right? So this is 20 over my adjacent, 21. And then switching things up, talking about tangent of B. opposite is 21, okay? All over my adjacent, this is my adjacent now, this is 20. And again, these are reciprocals of each other, okay? For 4, solve for y, it's the same concept. So I get that y squared plus 28 squared is equal to 53 squared. Y squared is equal to 53 squared minus 28 squared, and then y is equal to this big square root of the inside portion of this, okay? So let's go to our handy dandy calculator, clear this. We get 53 squared minus 28 squared is 45. So I get that y is 45, 45. Tangent of A is opposite over adjacent, 28. Now switching things up, talking about tangent of B is the reciprocal, so 28 over 45. Okay, cool. Now let's go to some blue for the ocean, right? So many real life situations, such as sound waves, weather patterns, electrical currents, can be modeled by sine and cosine functions. The table shows the depth of water in feet at the end of a wharf as it varies with the tides at various times during the morning, okay? So I want you to close your eyes really quick and just imagine like you're at a beach, the waves are coming in and they're coming out, right? Okay. You also have like some low tide and some high tide, so sometimes the water comes in more, sometimes the water is less, right? So they give us this time. So it starts at midnight and it goes up until noon, okay? And this is the depth of the water at the end of this wharf, okay? Okay, okay. So sketch the line that shows the average depth. So this is my depth here. Let's label this. This is D, and this is my time, okay? So my average depth, this is as high as it goes. This is its lowest. So my average depth should be somewhere along this. We can sketch that line to be there. Right? If you, it shouldn't really be down here, right? Because that doesn't make sense, right? And if you put it up here, that would be way too high. So it has to be somewhere here. If you would have done something like this, that's fine, but you want to be almost at the middle point of all of these, okay? Okay. Find the amplitude. So A is equal to 1/2 times high minus low. Okay, so that's very similar to what I talked about. So my amplitude is equal to, I like to use absolute value, and you should try to use absolute value of max minus min, so high minus low divided by 2, right? Same concept. So then A is equal to 1/2. What is my highest point? So from our table, my highest point is at 14.08. So 14.08 minus my lowest. This is my highest. We'll call this high. And my lowest point is 5.76. We'll call this my low. So this is my 5.76. Okay. Now I'm gonna bring this over and let's do it. So I have a 1/2 times 14.08 minus 5.76. Let me get that that's 4.16. So my amplitude there is equal to 4.16. Okay. Um, awesome. So find the period. So period equals 2 times low time minus high time. Since the normal period for sine is 2 pi, the new period for our model will be 2 pi over p. So b is equal to 2 pi over p. Okay. And then what do they want us to find? The period. So they want us to find, what did they asking us? They want us to find B. They want us to find B. So what is it? Well, first find the period, right? So the period is when will this repeat? Um, so when will this repeat itself, right? So if it starts off at here at midnight, we can make a little wave up here. So it repeats itself after how many times? How many hours, sorry? 12 hours, right? So um so B is so the period is equal to 2 times my load time. So when was the load time? So the load time was at 10 a.m. So we'll do 10 a.m. minus my high time. The high time was 4 a.m. This is equal to 2 times 10 minus 4 is 6 equals 12. So then my period is indeed 12, right? And that we can do it here and solve the way we did it here, which was 12. Or you can assume that from, I don't know if you've taken your science classes, but between a low high tide and low tides happens every 12 hours. If I could be speaking completely wrong, but yes, okay. And now my B here is a 2 pi over 12. This is pi over 6. Okay. So period is 12. My new B is pi over 6. Okay. Okay. So high tide occurred 4 hours after midnight. The formula for the displacement is 4 equals C over B. Use B and solve for C. Okay. So I know that 4 is equal to C. That's what I'm solving for, over B. So that's pi over 6. So then solving for C, I multiply this by pi over 6. What I do to one side, I do to the other. Very good. Now I'm left with C is equal to 4 pi over 6, which is simply equal to 2 pi over 3. I can simplify that further. I'm sorry, I can simplify it to this. Okay. Now I found my values for A, B, C, and D. Put them into an equation. So I know that this is y is equal to A. A was 4.16 cosine of B. What was my B? Pi over 6 T minus C. My C was 2 pi over 3 plus 10. Okay. Okay. This is one way to write this. You could have also written this as, okay, let's keep it like this. And then let's just say, or y is equal to 4.16 cosine of pi over 6 t minus 4 plus 10, so 4. Okay, so these are two ways of writing this equation. This is one way, or you could have written, oops, or you could have written it like this. They want us to write it like this because of the way it's given there. And all you can do that is you can distribute this out. Okay. Okay. So now I have this model. I have this equation. So use your model to calculate the depth at 9 a.m. Okay. And I really don't like the way they express this because so at 9 a.m. t is equal to 9, right? This is 9. Okay. So then how are we going to do that? We have to plug in 9, right? So then I'm going to call this a function. F of 9 is equal to 4.16 cosine of pi over 6 times 9 minus 2 pi over 3 plus 10. So let's go ahead and now we are more than definitely having to use our calculator. Let's make sure we are in radians, because now we are talking about the radian world. So we are going to radians, and I'm gonna set this as 4.16 cosine of, let's do pi over 6 times 9 minus 2 pi over 3, close those parentheses, plus 10. So I get 6.397 feet. So it's approximately 6.397 feet, right? This was in, well, it doesn't tell us. Yes, feet, feet, feet. Okay. Now let's think about this. At 3 p.m., that is how many hours after midnight? 12 plus 3, that's 15. So this is when t is equal to 15. Okay. Okay. So let's go ahead and just quickly go up here. Instead of putting 9, I'm going to put 1, 5. I get that's 13.602. So this is a 13.602 feet. Okay. So I'm using my model, right? This equation here to calculate my times. I am plugging in my times. Another way you can do this that I'm going to show you is to, this actually is easier. So I can graph this, right? So I'm graphing this equation, and I hope this kind of works. So if I have 4.16 cosine of pi over 6 times x minus 2 pi over 3, close those parentheses. Well, just delete this one. This is close. Plus 10. Okay. And I can go to the graph. No more shopping. Yes, that's correct. And and then I can go to the second graph, and I have a table here. So then at 9 a.m., that is 6.39, which is what I got originally, right? And then at 15 or 3 p.m., it's 13.602, right? So that's kind of like another way to do this. You can see it from a graph. And this is our wave, and we should be talking about positives. Okay, change my window. Let's just do 0 up until, let's say we want to see 4 days. I mean 2 days. So something like that, right? Okay. Um, Number 11, a boat needs at least 10 feet of water to dock at the wharf. During what interval of time in the afternoon can it safely dock? So in the afternoon, it needs at least 10 feet of water. So on my equation, I need to graph 10, 'cause that's 10 feet. So I need water, the times that the water has to be where? Is it going to be above or below? It's when the water is above, right? So what intervals is the water above? So you're talking about the afternoon. So somewhere here, right? So what point is this right here? What point is that? Um, we can do this using our calculator. So second, calculate, and we can go to intersect. My left bound is there, and my right bound would be there. So my intersection there is at x equals 13. So at 3 p.m., correct. No. Sorry. Uh, x equals 13. So that's 1 p.m. So it's when t is equal to 13 up to where? What's my other intersection point? Oop, right there. That's when x is equal to, I'll call that 19, and t is 19. So what times are those? So between 1 p.m. and 7 p.m. And they should have specified that time here is hours after midnight, just because of the context of it. You could have done this just by knowing that it's gonna repeat itself again. So, for example, if this was at noon, then you know that this would have been 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7. No, sorry, these are going by intervals of 2, so that's my bad. Noon, and then this would have been 2 p.m., 4 p.m., 6 p.m., 8 p.m., 10 p.m. Actually, ignore that. Ignore that. Um, Ignore that. So yes, okay, between 1 p.m. and 7 p.m. Okay, now go. Use the given solutions of a quadratic function and the y-intercept to find the original equation. So these are going to require us to do some work. I team to work. Okay, so um, okay, we've done this a little bit in the past, if I'm not mistaken. Um, Now we're talking about imaginary roots. So it's important to note that here they gave us two roots. However, if I would have just given you x is equal to -2 plus I, it's important to note that what? So the complex roots. So complex roots always come in conjugate pairs. So always come in conjugate pairs. So therefore, we know that this is a plus and minus 2. Okay. Um, okay. So our solution is we know the roots. So we know roots x is equal to -2 plus I, and we'll call this x2 is equal to -2 minus I. Okay. So we have two different roots here, and then a form of a quadratic when I have my roots can be thought about, well, we'll call these R1 and R2. R1, R2. There's a little bit of a review. Is R1 x minus R2 equals 0, right? Um, okay, so let's kind of jump into doing this. So if I have x minus my root, so -2 plus I, oops, close it, and x minus -2 minus I equals 0. So let's just kind of clean this up. So this becomes x plus 2 minus I, x plus 2 plus I equals 0. Okay, so we're going to talk about this y-intercept part in a little bit. Okay, we'll talk about it. So I know that there should be a little coefficient there. And for now, we can maybe ignore that. Well, no, we'll put this a in there just because this is my leading coefficient. I should have maybe done this since the beginning, right? Okay. I'm going to take this the long way today for this one in particular, and I'm going to expand everything out. So I'm left with a. I'm going to distribute everything. Okay, no shortcuts right now. I'm going to distribute everything. X squared plus 2x plus xi plus 2x, now I'm talking about the next one, plus 4 plus 2i minus xi minus 2i minus I squared is all equal to 0. Okay, now this, holy moly, right, looks messy, ridiculous, right? But all I did is I was distributing this out to all of them, right? So I'm multiplying little numbers. I'm multiplying a variable and a number, an imaginary number times a variable. We know how to do that. We're experts at that. So now we have a. Let's combine like terms. My x squared is by itself. Now let's think about 2x here, a 2x there. So that becomes 4x. That's the only thing I can combine, 4x. Now let's think about my xi. I have a plus xi here, a minus xi. So what's going to happen there? They go away. The plus 4 is there by itself, so plus 4. This 2i right here, so I have a plus 2i minus 2i. What happens there? They go away, okay? And then minus I squared equals 0. Now, it's important to note that I squared is -1, so here I have a x squared plus 4x plus 4 minus I squared is -1, so -1 here equals 0. This combines, right? So we get that a x squared plus 4x plus 5 is equal to 0. Okay, so we're getting a lot closer. My y-intercept is 0, 5. So what does that mean? So that my y-intercept is 0, 5. So when I plug in x, I should get a 5. Okay, so then my equation y is equal to a x squared plus 4x plus 5. I can plug in a 0 now and I should get 5. So 5 is equal to a 0 squared plus 4 times 0 plus 5. 5 is equal to a times 5. A is equal to 1. Okay, so then my function and my equation for this is f of x is equal to x squared plus 4x plus 5. Okay, now let's think about 13. I have to add a, where is this template? Okay, now might take a shortcut, not a shortcut here, but yeah, okay. So again, same concept here is that I have this, let's use a different color now. I have that x is equal to -3 plus I square root of 6, and x is equal to -3 minus I square root of 6. So again, my f of x function is equal to a leading coefficient there of x plus 3 minus I square root of 6 times x plus 3 plus I square root of 6. Okay. Now, there's something that I can do. And I can like kind of group these up here and then group this here again, right? And this is a difference of squares. So a difference of squares is a squared minus b squared is equal to a plus b, a minus b, right? So then here I have that is equal to a. What is my a? My a is going to be x plus 3 squared minus, what's my b? My b here is I square root of 6 squared. Okay? And now this helps us a lot more. Why? You might not see it yet, but it does. because we should know that this is x squared plus 6x plus 9, right? This becomes a lot easier to kind of combine. Put this in parentheses minus. Now, on the side, I'm going to do my work for I squared root of 6 times I squared root of 6. So then if I multiply them out, I'm going to get I squared times what? Times 6, right? So then I squared is negative 1. So this becomes negative 6. So then right here, I have minus 6. Going back to my purple, I have this is a x squared plus 6x plus 9 minus negative 6. So it becomes what? Plus 15. Okay. And now this was a lot simpler than doing all of this up here, right? They're both the same approach. But except here, I took a difference of squares. I was a little bit more intentional with my work. You could have easily distributed them all out too, right? Totally valid. Now I can use my y-intercept point that if I have at 30, so then f of 0 is 30. So then I would get that this is 30 is equal to a 0 squared plus 0 plus 15. 30 is equal to 15a. So then I get that a is equal to 2. So that my entire function here now becomes what? So I have that f of x is equal to 2x squared plus 6x plus 15, which is equal to 2x squared plus 12x plus 30. Okay, so let's just highlight this as your answers, and this is my answer. Okay, I'm going to do the next one using the long way, and we'll see if I don't make a mistake somewhere there, because sometimes the algebra can get messy. Okay, so again, my root 1 is equal to negative 5 plus 5i squared root 2. My root 2 is negative 5 minus 5i squared root 2. Okay, so then when I talk about f of x, leading coefficient, right, because I don't exactly know what it is, there's an a there, and this becomes x plus 5 minus 5i squared root 2, x plus 5 plus 5i squared root 2. Okay, now I'm going to do this one the long way, just so you can see that it's going to be more time consuming, right? But that is going to get you down to the same answer. Okay, and then I'm going to do the next one with the trick. Okay, so in case this did not make sense, if this did not make sense, you're able to simply do it the longer way. Nothing wrong with that. I'm teaching you different tools so that you are able to maximize your own learning, okay? So x times x is x squared. X times 5 is plus 5x. X times all of this, right? So this is where it might get confusing, but you get plus 5i squared root 2x, okay? And let's do it. Plus 5x plus 25 plus 25i squared root 2. Okay, so far so good, I think. And last but not least, I'm doing it here, right? So minus 5i squared root 2x minus 25i squared root 2 minus this last part is a little bit tricky. I did it here, minus 25i squared times 2. Okay, let's just kind of do it out so you can see it, because I'm multiplying these here, so I'm left with negative 25i squared times 2. Okay, okay. And then I can combine that, but we'll talk about that really quickly. Is equal to, a is just there, x squared. So x squared is my only one that's left. 5x. I have a 5x here, a 5x there. That's it. So that combines to make 10x, right? So plus 10x. Now let's think about this can go away with this. So that cancels out with this one. Okay. Now the 25 is my only one that's there. So plus 25. Now I'm left with this, and this is a minus. So those go away. Go away. Oops. Go away. And I'm just left with minus 25 times 2, which is 50 I squared. Okay, and again, that we know that I squared is negative 1, so this is equal to a x squared plus 10x plus 25 minus 50 times negative 1, so this becomes a plus 50. So this is a plus 50, so then I get that a is equal to x squared plus 10x plus 75. Okay, now let's double check. Is this my y-intercept? Is it correct? Let's do it. So then I get that f of 0 is 75, right? It has to be equal to that. So I'm left 75 is equal to a, 0 squared plus 10 times 0 plus 75 is equal to 75. So then I'm left that a is equal to 1. So then my f of x is just equal to x squared plus 10x plus 75. Okay. I don't like the color. Okay. So I know, it can be a lot. I understand. I get it. Okay. You have to take it step by step, right? Show all your work. You have to be very meticulous with your work. You have to be very organized. So you see how I'm going row. I'm going row by row. So I would do row by row by row. Take it step by term by term by term, right? Slowly but surely. It does the job. Okay. And now we are towards our last one. So let's kind of chunk it out. Paste. Okay. Let's use the, what color have I not used today? I've used purple. I haven't used this pink. Okay, let's use the pink. Okay. So again, x is equal to negative 1 plus 4i. X is equal to negative 1 minus 4i. So when I put this into an equation, I get that this is going to be x plus 1 minus 4i, x plus 1 plus 4i. Okay, so again, this, you can think about this as a difference of squares, right? So a squared minus b squared is equal to a plus b, a minus b. Okay, so then here I'm left with a x plus 1 squared minus 4i squared. Okay, is equal to, I'm going to keep this one in parentheses for now. And now I know that I have 4i squared is equal to 16i squared. So it's just equal to negative 16, right? So minus negative 16 here. And now I'm left with x squared plus 2x plus 1 plus 16. Okay. So now I can combine this. Is equal to a x squared plus 2x plus 17. Okay. Now I'm not done, right? because I have to use my y-intercept. So then f of 0 is equal to 51. So let's double check that. So 51 is equal to a 0 squared plus 2 times 0 plus 17. 51 is equal to a times, what is this going to become? Just 17. And I divide by 17 on both sides. And I get that 3 is equal to 8. So then my f of x is equal to 3 x squared plus 2x plus 17, which is equal to 3x squared plus 6x plus 51. Okay. So that was kind of doing it the shortcut way. If you didn't choose the shortcut way, I'm gonna do it out a bit. I'm gonna just forget. Oops. No. Forget these parentheses. Forget those. Forget those. And I'm just gonna kind of do it the long way. So I'm distributing this out, so I'm left with x squared plus x plus 4ix plus x plus 1 plus 4i minus 4ix minus 4i minus 16i squared. Okay, so a lot of things to combine. So I'm left with a x squared. There's a plus x here, a plus x. This becomes plus 2x. Now I'm left with plus 4i plus 4i here. This becomes plus, wait, what? Did I do this wrong? So x squared plus x plus 4ix. Oh, so exact. So it's my bad. So 4ix is together minus 4ix is together. So they go away there. So they go away there. And then I'm left with a plus 1. And then this 4i. So 4i minus 4i, they go away as well. And then I'm left with a minus 16i squared. So again, I squared is negative 1, so this becomes a x squared plus 2x plus 1 minus 16 times negative 1. So then you can see that this is still going to be, this is a minus 16 times negative 1, so plus 16 plus 1 is plus 17. Okay, so that's exactly what we got earlier in the very beginning. Then you would use the same concept of using your y-intercept, and you would get that a is equal to 3. So at the end of the day, you end up getting the exact same answer that you would have gotten if you had done it the other way. So really up to you. If you're able to recognize a difference of squares, it does save you some work, but it is not really easier than the other one. It just saves you more work. But the concept of here, how they cancel out, that's also pretty straightforward, okay? And then that helps you. So that was a lot, but I hope it's all making some sense. Please come to office hours if it does not. And yeah, have a great rest of your day.